3-7, the title is GCF and LCM, which doesn't make a ton of sense, but GCF, we're going to start with that, Roman numeral 1. It's greatest common factor. So maybe it does make sense. You've seen it before? Cool. So greatest common factor. Lowest common multiple. So it sounds like it's all review. Which, if it's all review, means it won't take us that long as you guys are on track. So if you know this already, maybe don't write down the stuff that you already know. I'm just going to kind of lay it out there and assume that some people have forgotten it. But factors are the numbers that something's divisible by, and that's what we were working on in the last section. So the numbers something is divisible by. So, for example, 6 would be divisible by 1, 2, 3, and 6. You know, what numbers could you do 6 divided by that number and have it work out nice? So I'm going to write out like 2 different ways to do this. And I'm going to switch to this. So way number 1. I suppose if you wanted to, you could have like a capital A and a capital B if you want to kind of try to organize your notes. With those then, if you're trying to find greatest common factor, one way to do it is to list the factors of the 2 different numbers, and then the greatest common factor is the one that they have in common that's the biggest. So way number 1, list the factors of 2 numbers, and then the GCF, the greatest common factor, is the largest one they have in common. Is the largest one they have in common. And figured just do an example of that real fast. So if we were to say find the GCF of 30 and 48. So find the greatest common factor of 30 and 48. So you could go through and use those divisibility rules that we had before and say, well, 30, is it divisible by this? Is it divisible by this? Is it divisible by that? Unfortunately, this one's not going to be too much of a pain. What I often do is, well, it's divisible by 1. I do them this way. 1 and what give you 30? 1 and 30, so I'm going to take and put a 30 on the end. Sometimes this gets a little sloppy. It's like, oh, there's more numbers and you're trying to squeeze them in, or there's less or something like that. But 30 is also divisible by 2. And 2 times what gives you 30? 15. So I'm going to put my 15 over by my 30. So then it's at least in order. Is it divisible by 3? Yep. 3 and 10. Another number, 4. Divisible by 4. Nope. And for me, I think like, okay, 4 would be like 20. So then you have 24, 28, then 32. So it's not by 4. By 5? It'd be 5 and 6. Oh, cool. And once you kind of meet in the middle, then you know there's no more, because you already checked 6. Well, that's divisible by 6 gives you 5. Divisible by 10 gives you 3, and so on. All right, so we have that one. We could do the same thing with 48. Yeah. But 10's already listed right there. So kind of like once you get to where you're 5, it's not that my 2 just met here in the middle because I'm out of space then, but it's because, well, when you have 5 times 6 gives you 30, then you know you don't need to keep checking 6, 7, 8, 9 because those would have been covered over here in those. That's the method of the madness. Anyways, so okay, so now if we were to do 48, so 48 would be 1 and 48. I think I'm going to need more space than that. Let me move my 1 over. 1 and 48. 2 and 24. 3. Is it going to be divisible by 3? 4 plus 8 is 12. Is 12 divisible by 3?
Oh, yes.
Yup. So what times 3 gives me 48? Well, it's going to at least have a 1 because that gives me the 30.
11.
There's 18 left. 18 divided by 3 is 6. So it's 16.
I knew someone was going to do that.
4.
I said 21 like I thought it was 20.
48 divided by 4 is 12. 48 divisible by 5? 6. Maybe. 6 would be 2 and 3. Okay, so 6 and 8. Is that what it was? Nope, 6 and something. If we divide it by 6, 6 and 8. You're right, 6 and 8. So mine's really sloppy, but 6 and 8, 12, 61. So now if we want to get the greatest common factor, we just look at what do they have in common. 30, 15, 10, 6. You're right. So some of you beat me to the answer, so it's going to be my 2 6s. So 6 then is the greatest common factor of 30 and 48. Does that make sense for a way? A second way, and really it's just up to you which one you prefer. I did orange. Okay, so if we go with the same color scheme, B is way number 2 or method number 2. Way number 2 is going to be prime factorization. So do prime factorization. Or in other words, get a factor tree. So prime factorization. And then the GCF, the greatest common factor, equals the product. Product, are we adding or multiplying? Multiplying. Product of the common prime factors. And I'll just stick with the same 2 numbers again. So let's say we have like 30 and 48. So 30 and 48. Well, to do one of those factor trees, I usually, if it's even, I usually do 2s as long as I can, just to make the numbers smaller. So I'm going to start out, say 30 is divisible by 2, and I get 15. Unfortunately, 15's odd, but 15 could, not divided by 2, it could be divided by 3. And that gives us a 5, yes? So 2, 3, 5. If I do the same with a 48, I'm going to start with 2, and I'd have 2 and 24. Still even, so I'm going to pull another 2 out of there. 2 and 12. So 2 and 6. And 2 and 3. Now, we set up here, the greatest common factor is going to be the product of the common prime factors. So we're saying, well, what ones do they have in common? Well, this one has a 2 and a 2, and doesn't have any more 2s. This one has a 3. This one has a 3. The blue one doesn't have a 5. So in other words, 2 times 3, the product of the ones they have in common, give us the greatest common factor of a 6. So it's really kind of up to you. Do you like doing those divisibility rules and trying to like hit all kinds of different ones? Or do you prefer the prime factorization, these factor trees? I'd probably do this one, personally. But if you prefer the first one, knock yourself silly. At this point, I'll warn you before the test, especially if you ask me. I don't think I'm going to ask you to do one this way and do one this way. I think just figure it out, whichever one you like. Yes, ma'am?
Well, I have 2 questions, but they might be kind of...
The last section then is going to be Roman numeral 2, which is the LCM, or the least common multiple. Least common. I always thought that this was easier, unless you get like some totally psychotic numbers. But first thing is probably kind of too elementary for you, but like multiples of 5 are like 5, 10, 15, 20, 25. It's probably not worth writing. I'm going to do it just to prove my point. Multiples of 5. So those are going to be like 5, 10, 15, 20. And again, you probably don't need to write these, ... But how we get the multiples of 5 is, well, that's 5 times 1. This one here is 5 times 2. Then we have 5 times 3. Or you just really count by 5s. Fair enough? I just wanted to throw that out there to say, like, what are multiples, kind of what are they? But so the least common multiple, what is that? I'm going to put a little star by it for dramatic emphasis and say that LCM, least common multiple, is the smallest number So is the smallest number that's a multiple of two different numbers. So least common multiple is the smallest number that's a multiple of two different numbers. And to do an example of that. All right, so for an example, find the least common multiple of 5 and 7. So find the least common multiple of 5 and 7. It's written there. What I would just do then is start by listing them off. So if I have 5, well, 5 it's going to be 5, 10, 15, 20, 25, maybe start there. For 7 it's going to be 7, 14, 21, 28. That we're just really adding 7 every time. So far we don't have any overlapping. Dot, dot, dot. And then, yep, 35 ends in a 5, which now I can't write it because I'm saying it. 35 ends in a 5. And then once you have that, you see, hey, look, it must be a multiple of 5 also because it ends in a 5. Awesome.